Hello and welcome to yet another Chi-Prime video where we solve a problem to prepare for the GMAT. As usual, I'll give you a second to pause the video if you'd like to solve the problem yourself, and then we shall proceed to solve the problem together. Alright, so let's begin. Here we're given, it's a problem from statistics, and here we're given that the mean, the unique mode, and the median of a list of 5 positive non-zero integers are all equal to 5. So let's just say the 5 positive non-zero integers are A, B, C, D, and E. So now we're given that the mode is unique, which means that, and the mode is equal to 5. So let's say mode equal to 5, and it's unique, which means that at least 2, if not more than 2, are equal to 5. So this means two things. One, 2 or more of A, B, C, D, and E are equal to 5, because that's the unique mode, and no other integer occurs more times than 5 does. Right? Because the mode is unique, and the mode is the most frequent occurrence, and that happens to be a 5. So there's at least 2 5s in A, B, C, D, and E. So that's one thing we get from the mode, the unique mode being equal to 5. The other idea that we get from here is that the median of the list of 5 positive non-zero integers is also equal to 5. Now let's assume that A is less than B is less than or equal to B, less than or equal to C, less than or equal to D, less than or equal to E. Right? Strict ordering. In this case, the median is also 5, which means the median of 5 numbers is always the middle number, right? So here, this is telling us that C is equal to 5, right? So putting the two things together, this is from the median. From the median, we know this, and from the mode, we know there's 2 or more are equal to 5. So let's assume that there's only 2 that's equal to 5, just to test out the other conditions. Right, so now we know there are at least 2 5s in list X, so we know A is true. And we're trying to test the rest of the assertions. Right, so now we know that of A, B, C, D, and E, there are 2 5s. There are 2 5s. At least. And C is equal to 5. So what are the possibilities? You get blank 5, 5, blank, blank. That's one possibility. Another possibility is blank, blank, 5, 5, blank. Those are two possibilities, right? Because we have at least 2 5s. Now, admittedly, more of the others could also be 5s, but this is the least number of 5s that we are working with. So blank 5, 5, blank, blank, or blank, blank, 5, 5, 5, where A is the smallest, E is the largest, and the others are moving from left to right, or less than or equal, B is greater than or equal to A, C is greater than or equal to B, and so on and so forth, moving from left to right. Okay, so now let's see what other numbers we can fit in. From these two statements, we understand that A plus D plus E, right? Since the mean is also equal to 5 of these 5 numbers, the mean of A plus D plus E in this case, in the first case, the mean of A plus D plus E should be equal to 5, right? Because the other two numbers are 5s already. So A plus D plus E should be equal to 15. Or in this case, A plus B plus E equal to 15. That's what we have to have, right? For the mean of the 5 numbers to be equal to 5. Or the sum of the 5 numbers to be equal to 25. So A plus 5 plus D plus E is equal to 25, which gives A plus D plus E equal to 15 in the first case. That's case 1. And in case 2, A plus B plus 5 plus E equal to 25, or A plus B plus E equal to 15, which is case 2. Right? Now, we're also given that the list of 5 positive non-zero integers are all equal to 5. And we already said that they're ordered, sorted order from left to right. So they're increasing or equal, going from left to right, right? So A is the smallest, E is the largest. They may be equal, but in the worst case, A is the smallest, E is the largest. What is the smallest positive non-zero integer we know. Smallest positive non-zero integer is 1. So if we said, let's say a equal to 1, say a equal to 1. In this case, let's try out case 1. Case 1, right? Hypothetically. If we test the assertion that a equal to 1, we end up with 155 blank blank. Now we know that 1 plus d plus e from this equal to 15, or d plus e equal to 14, and d has to be greater than or equal to 5, right? So let's say if d equal to 5, e equal to 9, d equal to 4, d cannot be equal to 4, right? Because d is to the right of the median, which is c. So d can be equal to 6, in which case e is equal to 8. So the first equation, case 1, if a equal to 1 yields e can be 9 or e can be 8. Let's look at case 2. Here we have blank, blank, 5, 5, blank. In this case, let's say a equal to 1 again. So we get 1 plus b plus 5 plus 5 plus e equal to 15, or 1 plus b plus e equal to 15. B has to be less than 5 because it's less than or equal to 5 because it's to the left of 5. So you have 1 plus, let's say b equal to 2 plus e equal to 15. 1 plus, let's say b equal to 3 plus e equal to 15. Or 1 plus b equal to 4 plus e equal to 15. Or the last case, 1 plus b equal to 5 plus e equal to 15. So in the first case, we get e equal to 15 minus 3, which is 12. Second case, we get e equal to 15 minus 4, which is 11, then 10, and then 9, right? So the largest value that you can have for e is 12. It's not 9. So yes, not all numbers in the list have to be equal to 5, so b is true. The largest possible integer in the list is 9. Unfortunately, that is not true, so c is false. Statements A, B, and C are all true. That's E is false. And only one of the statements of A, B, and C is false. That is correct. So we have 3 possible answers, of which this is the most accurate. Only one of the statements for A, B, and C is false. So D is the answer we want. Thank you for watching.